So let's start prepping for Tensorflow because the certification is soon going. Just as a reminder, last day to purchase the Tensorflow certificate exam is 30th April, only 8 days from now. So for only 8 days, you can buy this certification and then exam to take the exam. You have 1 month of extra time. So last day to take the exam is 31st May. Okay. So get the certification, buy the exam coupon. You can study until May. Okay. So let's start with the TensorFlow certification link. So unit number one, in if you check the candidate handbook, it talks about unit one being just introduction to TensorFlow. That is what I'm going to do now. What is TensorFlow? Think of, I think a good example might be MATLAB. The company's name is MathWorks. I really like how the name is because it talks what MATLAB is based on. It is based on maths. If you use Excel, okay, you have a tabular data. If you use databases, you have a tabular data in which there are columns and there are rows. In columns, you have some values, and then in number of rows will be the instances of different things. So this, if you translate, it is represented using maths and a computer which allows you to take that maths. For example, you have four different columns in an Excel sheet and they have some specific values. Mathematically, it's a vector. Internally, it is represented as a vector. And ability to do this vector manipulation, it could be different things, which is, linear algebra. The whole domain of linear algebra is, dependent on this vector. So what we have, what is TensorFlow? TensorFlow is nothing but a library which allows us to do this. So even MATLAB could help us do that, or we could use TensorFlow, which Google has built. So TensorFlow is a tool which helps us do mathematical linear algebra because everything in the end goes to maths. Okay. So this is TensorFlow API. It is dependent on just the vectors thing. What it is it is something which is inspired from our human brain. Every brain is a connection of neurons. Whenever you learn, let's say when you're growing up, let's say when you are hit by someone to discipline you, you got a feedback and that connection was made. You learned something that happens through these connections of neurons. TensorFlow allows you to build the exact same thing. Here, if you look at this neural network, okay, these eight boxes, square boxes, they are the neurons. So in this network, we have eight neurons and then we have two neurons. That's it. So in TensorFlow, if you check, we will check, scroll down and check just the first code. So in first code, if you are new to programming, just look at TensorFlow as a tool which helps you train neural networks and focus only on the neural network part. Okay. Here, what we are doing is we are simply building data for us to learn from. That's what neural networks do. Okay. I will explain this when I'm going into the code. For now, focus on the network part. So what do we have here is whenever you see dense, that will tell you that those are the number of neurons. So here, if you pay attention, we have two layers. There is this layer, okay, and then there is this layer. There are 128 neurons in this layer, which is the second line of this neural network, and there are 10 neurons in this neural network, which is the fourth line. In TensorFlow Playground, we have two layers. I can't increase it more than 8. That's why I'm limited to showing this, but we have 8 neurons and 2 neurons here. Okay. Or 6 neurons here, whatever. This is what the code says. And TensorFlow allows us to write the code and then simply do the learning from the data in one shot. So you define the architecture. Okay, you define, how's the network, how's the design, blah, blah, blah. You do that. You define the architecture. And then you simply say, you know what? I want to do the minimization of error, and I want to learn whatever the thing I'm trying to learn. Okay, so TensorFlow allows us to does that. Now we will see that in code. Okay, so let's see. This is the unit 1 for TensorFlow certification, where we are understanding basics of neural network. Okay, we start from here. If you are starting from scratch, install Anaconda software, which installs a Python library, Anaconda Python, if you search, and then this you can simply start coding on Colab. Python is a language which is very close to English. So look at the English part and focus on the just the neural network part, the design. Okay, these many layers, these many neurons. You can do it like this. So here, whatever we want to use, it's like cooking. Whatever are the essential libraries we need to use, we import them here. What are these libraries? These libraries have all the functionality we need so that we don't need to write it from scratch. See, the name tells you dataset is a dataset specialization. This is TensorFlows and this is our TensorFlow API. Okay, so I'm executing this and I'm done. So here I will do this neural network in a bit differently. If you check, this is the line, first layer. Let me write it here. First layer. And this is the second layer. If you check how our brain works, our brain has a cortical column. It has 6 layers. Our entire brain is just a small thing, and it has only 6 layers deep, and through that entire intelligence is achieved. Even genius or genius max or whatever. So here we write 2 layers, 8 neurons and 10 neurons. And the data I am giving is a very interesting data. So what we are doing here in this, check how many number of lines we have here. Just 21 lines. And in that there are a lot of blank lines. So essentially, ideally it is just 3 lines here, 4 lines here. This is 5 lines, 6, 7. So in 7 lines only, what are we achieving here? I will show you. So I've started executing this. It has quickly done something. But in the end, if you check, it tells us this final thing, accuracy of 90%. What is this accuracy of? Let me go to this MNIST. Always check whatever data set you are learning on, check on Hugging Face. Okay. So check the data set and you will find what is this problem. This problem is image recognition. Okay. This is, we learn something this in our KG. We learn to identify alphabets A to Z. We learn to identify digits. Okay. So that intelligence, if you want a neural network to do, that is this problem. This is such a small basic problem. Okay. But thing is, if we can solve such a basic problem, we can also solve a much more complicated problem also. That is the logic of this deep learning field. By using TensorFlow in less than 7 lines, if we can solve this small problem by simply replacing this problem with a different problem, a more complicated and valuable problem, can we solve it the same way? And answer is yes. Okay, this is where this thing comes from. So we have achieved accuracy of 90%. Means the current model checks a digit, it does a prediction on it, and that prediction is correct 90% of the time. So only 10% errors. Okay, in less than 7 line using this TensorFlow API. And if you check, it has a very nice design also. Okay. One important thing is TensorFlow to know is TensorFlow is not alone. TensorFlow has this toxic codependency on Keras. They have a very long history. Keras was a separate library, then it became more popular. So TensorFlow is like, you know what, I want to, use your API so that, I also become more popular. Then they got combined and they together became less popular. Now they're separating again. So it's a very complicated, toxic relationship. What it Keras is a very simple way of looking at things. Check what it is doing. We import Keras. Everything we need to use is inside Keras. Okay. So Keras.layers gives us list of all the layers and whatever we extra might need. So this is we achieve 90% of accuracy using this less than 7 lines of code. It takes, let's say, 7. This is a small 28 by 28 pixel image. We know it's 7, but model also knows it's 7. In less than 7 lines, we achieved that. Okay. So what are neural networks? Neural networks are general pattern learning machines. The general word here is very important. If we give it a different data, it will learn from that data set also. So something we learn in our KG to learn to identify digits. The same approach we can learn to identify, let's say, real-time factory details to optimize factory maybe, or real-time student recommendation or recommendation on Amazon. Whatever the problem you are working on in your job, whatever place where human intelligence is being applied, we can give that same data and we can have a intelligence like human with us. And by using TensorFlow, we can build that intelligence. Now, companies are making a mistake. They're trying to automate all the human intelligence, and that's just plain stupid. Human intelligence is very, very, very amazing compared to this brute force neural network, which is just 7 lines. Our brain has less than more than 1000 different kinds of intelligent modules. It has different more than 10, 20, 30 different ways, types of neurons. It has a different ways of communication. There's so much complexity that our brain is very much intelligent compared to these things. So companies are looking to replace human intelligence. That's the wrong approach. Individuals should learn intelligence with TensorFlow to complement their own intelligence. That is how we should look at. Don't look at from company's POV. Companies being myopic. Look at it from your POV. You can use it as a very important tool. So neural networks are these general pattern learning machines, hereby doing nothing in just 8 units. In just 8 neurons at the first layer, we actually achieved a accuracy of 90%. And if you just change the data set, there are so many different data sets on Hugging Face. So if you write a neural network which can do this, in the end, all you're doing is just changing the problem and changing the type of neural network, but it remains a neural network only. So ideally, you could build a GPT, chat GPT, in less than 200 lines. Of course, it will take a lot of GPUs to train it, but the thing is that powerful of intelligence can be written using TensorFlow API in less than 200 lines. And now that is amazing. So this is end-to-end neural network. We have TensorFlow as a library. We also have Keras as a library. So if you want to know Keras TensorFlow as a library, this is TensorFlow library's documentation. Go to TensorFlow website and go to API. API gives you everything TensorFlow can do here on the left hand side. As you can obviously see, there is a lot more things here. One does not need to remember all of it. We just need to know essential things. What are essential things? I'll tell you. Our intelligence is learned on data. So tf.data is an important module. Our intelligence, then we start building neural network for it. And for neural network, we have tf.nn. And here, everything related to neural networks you can find. Okay, so we have tf.data, tf.nn, and if we need random data, then tf.random we can use, and done. tf.train for training. That's it. But as I remember, I told you TensorFlow is married to Keras. Now this Keras tries to simplify a lot of things, and then you will have Keras APIs which are different as a part of TensorFlow. Now, for Keras, don't go into TensorFlow documentation. Go directly to the documentation of Keras library. So these two entities, they haven't been able to merge really well, and the place of this intersection has some messy things. So TensorFlow as a API, we learned how to use it. Now we are looking at how to get the API help. TensorFlow API, you can go from this documentation, and for Keras, go to Keras library separate documentation. It is a lot simpler, and you will find in just one shot what all do we have. So look here. Here at the right hand side, we have layers API. Layers are, these layers. If I add more number of neurons, so I told you our brain has 6 layers. I don't know if I told you though. So these are layers, and Keras has this. Different types of layers, they're all part of this here. Their way of using is extremely simple. We just have to do keras.layers. Everything is part of keras.layers. Everything is part of keras.layers. Okay. Then we have optimizers. So then we have keras.optimizers, and everything here is in one place. So this is amazing. So just by using keras.optimizers, you have access to all the optimizers in one place. Similarly, just by doing keras.matrix, we have all the matrix in one place, keras.losses, everything in one place, keras.data loading, everything in one place. And as you can see, these are the important ones. And this is why Keras API was actually merged into TensorFlow to make things easier, but it has become a bit more complicated. But I hope this thing simplifies your load. When you are writing neural networks, focus on using keras, just smallest number of lines, get the accuracy, get to the end, and then you are at an amazing place. You can start doing neural network coding. You can be a developer, you can be an analyst, you can be a financial analyst, you can be an artist, you can be a student, you can be anyone. This deep learning is a general technology which anyone can learn and use. So this is the TensorFlow's. I talked what is API. I said where is the documentation if you want to start doing some coding. So this is where you can find details of how to use something. So these two places. And then if you are writing the code and there are some errors, then for debugging, you can actually just search on Google, search on Stack Overflow, or we also have Gemini. Use Bard Gemini a lot. This I'm still trying to get into habit of, but don't get stuck into things. This is a lesson for me also. Move forward, get to the end-to-end pipeline, and then you can improve on the code. So for debugging, if you can use Gemini, use Stack Overflow, or use different modules in TensorFlow. Okay. So this is part of the unit number 1 of TensorFlow candidate handbook. So where am I? TensorFlow candidate handbook. This is the unit 1 of 5 units we test in the TensorFlow certification exam. In unit number 1, it's the basic of Python coding, basic of TensorFlow API, where to go in documentation. Okay. Then whenever error comes, how to go to the documentation and check what is the actual way to do things. For example, if I want to use, let's say in Keras, I want to use a specific layer. So it will give me example of how to use it and what error I might have done. I can easily debug. So going back to the candidate handbook, then go to Gemini, go to Stack Overflow, and end-to-end pipeline of our TensorFlow library. So this is unit number 1. There are a few things I did not take. I didn't take these things because in unit number 1, this is not important. My recommendation to you is master just this. Change the data set here, change the neural network here, See what happens if you do instead of 8, if you do 80. What happens? How much accuracy do we get? What is the impact on this? What if we change the problem? What if instead of MNIST we load a different data set? Would that make a difference? What difference would it make? Can you visualize and see, oh, for this, that is the problem. For digit recognition we had a black and white data, and for this new problem we have a even more complicated problem. So you will have these experiences and you will be able to compare these things with each other. So I recommend you write the code, you change the numbers, check, increase number of neurons, see what happens. Look at the type of problems. So first problem is MNIST and second problem is CFAR. These are just names. Don't get carried away in it. Look inside the data. Inside the data, you will find small images, just like MNIST, which was a digits images. These images are of a specific type. You have some animals, you have some small things. What difference does it make? Let's check. I will do CFAR 10. And let's run the same model. Nothing changes because it also has the 10 same number of classes. Shape was 32. Input 32, 32, mm, and I think it's 3. Just one change and check. In the case of digit recognition, we achieved 90% accuracy right out of the bat. But when we change to this extremely simple, still simple, in digit recognition, we were recognizing 10 digits, which were very small, 28 by 28 pixel. In here, we have 32 by 32 pixel. Image is colored. That's all it is. And we still have 10 different classes. Here, oh, this is fun. This part, you see all the classes. So the first one is airplane, second one is automobile, bird, and these are the 10 classes we have here. And here we have, these were simply labels, right? So just with this, the code gave us much lower accuracy. So in intelligence, how to kind of like when a problem becomes complicated, what changes do we do to still get high accuracy? That is what we learn in rest of the units. For right now, master this code, impact of changing different things, check TensorFlow playground, build some intuition, and then in next lecture, I'll go into a bit more details and talk about rest of the essential stuff you need to know.